Milanka, you are preparing for HPCL, right?
Yes, sir.
And today you want to give the snap for which subject?
Sir, machines.
Electrical machines.
Yes, sir.
Okay. Tell me one thing.
Yes, sir.
Why we study the machines?
Sir, why we study the machine? Because to generate electrical power and wind, and how we are getting from where you will get, sir, electrical output through electrical machines only. So the generator and motor, everything we are going to study about how mechanical power is getting converted to electrical and how electrical energy is getting converted to mechanical. But these things, for all these things and its applications, usage is in vast industrial purpose use, sir. So that's why we are studying about this subject.
Okay. Okay. What is transformer?
The transformer is the static device which transforms input energy into output energy, making frequency as a constant.
Okay. How the transformer is being divided on the basis of construction?
I mean, means parts of the transformer, sir, or means primary, like primary core, consists of a core.
And how the transformer is being divided on the basis of construction? Construction wise transformer को कितने part में divide कर सकते हैं?
Like core, primary winding, secondary winding, and it's
these are the part of the transformer, no?
Yes, sir.
So I'm asking about the division of transformer, the type of transformer.
Core type and sandwich type.
Okay. How this core type and sandwich type are performing?
Sir, in core type, winding is going to cover the core, and in sandwich type, core is getting covered by the winding itself, sir. I mean, core is covering the winding, whereas in core, winding is covering the core, surrounding the core, and the amount of leakage flux is more in sandwich type of winding compared to core. And efficiency and output power is very high in sandwich compared to core type. And the amount of insulation and the amount of copper usage is more in core winding, sir, compared to sandwich type of winding.
Okay, so what do you use of the copper?
Sir, copper, we are using copper for the flow of current in the transformer, sir. We are using for conductivity purpose. We are using copper to get the EMF induced into the winding.
Okay, what do you understand by the rating of transformer?
The rating of the transformer is nothing but it depends upon the losses, and I mean the losses directly depends upon the temperature rise of the core. So the kV rating is about to prescription giving the rating of about how much voltage and how much current the given device is going to operate.
Okay. In the transformer, in the iron core, okay, the iron core is being joined.
Yes, sir.
What is the reason behind it?
Sir, the iron core is joined because to avoid any kind of air gap in the core. To reduce there shouldn't be. We have to be sure that there shouldn't be any kind of reluctance which is caused by the air gap, so that there will be a high amount of flow of flux in the core.
Okay, what is the permissible magnetic flux density of a transformer core?
So 1.6 Tesla, sir.
Okay, is there any specific reason?
Generally, we are using for CRGO that is the saturation level of maximum magnetic flux density. I know on that basis only, sir.
Okay, if we divide the transformer right on the power rating, right? We have the power transformer, auto transformer, and a step up or a step down transformer or distribution transformer,
Yes, sir.
right? So, what are the uses? Particularize, give the example of each type of transformer where it is being used.
Sir, we are using the power transformer mainly at the source side, at the generating station side, because the amount of the power which is getting from generator, we are going to step up the for stepping up purpose, we are going to use the power transformer. And
Mhm.
for power transformer, the voltage is going the voltage is going to be get transferred using transmission lines. After that, we are using we can use we are using auto transformer only. Uh, uh, Auto transformer is going to be used for variable purpose only, sir. Whether we want to vary the output voltage compared to input voltage, for that purpose we are using auto transformer. And we are using from again from distribution substation, from substation to distribution side, we are using distribution transformer for consumer side, sir. Where the constant where we uh, where we are going to stepping down purpose the voltage to the consumer terminals.
Mm. Anything specified about the rating of a transformer?
So,
It is KVL or it is okay. Why the rating of a transformer is measured in KVL?
yes, sir. KVA, sir.
Mm-hmm.
Its rating is measured in KVA. It is nothing but the product of voltage and current.
Yeah, why?
So because here the losses which are going to be created like core losses and variable losses are going to be occurred because of voltage and current, sir. Here the variable losses are directly proportional to the flow of current, and the here the constant losses are directly proportional to the voltage. So based upon
Mhm.
these things, the temperature will be deciding. So that's why we are considering these two as the main stand ratings.
Okay. The test in a transformer, it is short circuit and the open circuit, right?
Yes, sir.
Does it the case with the auto transformer also?
For auto transformer also, yeah, same, sir. The thing only here is the mm,
How it
mm,
is being performed?
sir, in auto transformer, we are going to short circuit the voltage. I mean, we are going to short circuit the secondary side, and suppose if we are going to conduct open circuit test, so we are going to open circuit the whichever is the high voltage, that side we are going to open circuit it, and we are going to measure current from the another side. I mean
Mhm.
voltage from the another side. And similarly for the short circuit also, we are going to short circuit the low terminal voltage side, we are going to short circuit, and we are going to measure the current from another side, sir.
Okay, how the transformer and the induction motor are related?
Sir, induction motor is works on the principle of transformer with the secondary side short circuited, sir. I'm,
Mhm.
it
Okay,
is
in
a
the induction. Yeah, yeah.
it is a rotating machine, and it is a static machine, sir.
Mhm. Anything related with the efficiency?
Sir, efficiency of transformer, uh, efficiency wise, transformer is high, sir, because in transformer there is no any kind of air gap, but in case of induction motor there is a lot of air gap, and also the no load losses are going to be high, because no load losses are it is around 30% of the full load current, whereas in transformer it is going to be around 0.05 I mean 5% of full load current. So the efficiency is going to be high in transformer only.
Okay, what are the disadvantage in induction motor? We are using a star delta connection starter, right? In the induction motor, what are the disadvantage of having a star delta starter?
uh, Disadvantages in star delta transformer is the
Star delta starter, not transformer. Star delta starter in induction motor.
So in star delta transform, I mean in star delta starter, there is, I think, the current is getting reduced, sir,
By what factor?
by three times, one third of the input current. I mean the current is getting reduced by three.
Mm.
So that is the only disadvantage, sir.
Okay. Anything more?
No, sir. Actually, that is the
If suppose
only. But
induction motor, okay, if suppose induction motor run at a synchronous speed, then what will happen?
what's an induction motor? When it will run at synchronous speed, it won't run, sir. It is going to be stopped.
Mm.
There will be no relative speed. So induction motor is going to be stopped. There will be no induction motor.
Okay. The slip ring in the induction motor. What does it?
What,
What
sir?
does it help in adding the achieve the induction motor efficiency?
Sir, what, sir? I didn't. I mean, voice got break.
Okay, what does the slip ring do in case of induction motor?
So slip rings we are using in induction motor to connect to the external resistor to vary the starting torque. For
Okay.
that purpose, we are using slip rings.
Okay, we study the circle diagram.
Yes, sir. But
Okay.
I
Okay, so what are the features that comes from the circle diagram while determining the efficiency of a induction motor?
sorry, sir. I didn't study the topic circle diagram.
Okay, suppose induction motor is varying the speed from no load to full load.
Yes, sir.
Okay, so how this speed is being achieved?
Sir,
And what
from
is
no load to from
and
no load to yes, sir.
what is the speed variation?
Sir, from no load to full load, speed is going to decrease a little bit, but slip is going to vary a lot. I mean, slip is going to decrease, sir, from no load to full load.
Okay, construction wise, when we are talking about universal motor and DC series motor, how much these motors are vary in the construction point of view?
Sir, in construction point of view, I mean, DC series motor, universal motor, DC series motor is going to act as a universal motor if we are giving AC supply. I mean, if you remove the commutator, it is going to behave as a universal motor, sir. I mean, supply is going to be AC, torque is going to be unidirectional. Then series motor is going to be act as a universal motor.
Hmm. Okay, and how this universal motor runs?
Runs means I mean synchronous speed or what like that.
No, no. How this process is being going on? It is the unidirectional or it is the bidirectional?
Say unidirectional.
Okay, how this unidirectional speed is being achieved in case of universal motor?
What's that?
How this universal direction is being achieved?
In by placing a commutator output side, sir. I mean armature on armature. If we are replacing with commutator, then we are getting DC output.
Hmm. Okay, does the armature reaction also add the feature in universal motor?
Armature reaction also. Yeah. Yes, sir. Armature reaction will be there in all the motors, but armature reaction will study mostly in induction motor only, sir. Not in not in these motors because the amount of air gap is going to be large in induction motors only, not in these motors, sir. That's why
Induction
the
motor induction motor has the armature reaction.
I mean synchronous machines are uh, um, having this armature reaction effect, sir.
Synchronous machine and induction machine have the armature reaction.
Yes, sir. Sir, I got some.
Tell me one thing. Why the armature reaction is absent in induction machine, but it is present in DC and synchronous machine?
Yes, sir, because sir, in induction, I mean, in induction motors, we are using a large air gap. So the amount of flux linkage with the, I mean, leakage flux is going to be not, I mean, leakage flux is not connecting with another winding. So here, the demagnetization and magnetization effects are going to be nullified here. So that's
What
why
is
we
the
are
must
not.
condition? Okay, what is the must
What's that?
condition to have the armature reaction?
Sir, to have an armature reaction, I mean, the armature is going to produce a flux which is going to opposite the field flux. For that purpose, the amount of air gap, if the amount of air gap is going to minimum, then definitely the flux is going, leakage flux is going to be having some mutual flux with the inside the rotor. That's why we are having armature reaction effect in these two motors, sir. Not in that's why due to large air gap, there is no any armature reaction effect in induction motor.
Okay, last question. Why the synchronous motors or synchronous machines have the larger air gap when compared with the induction motor?
So to get a high due to that short circuit current is going to be less and uh,
I don't think this answer is suitable.
then
Anything more?
then no, so some disturbance is coming from outside, that's why. 1 second.
No, I'm talking about the answer.
Yes sir, tell me sir.
Yeah, why the air gap is more in case of synchronous and less in case of induction?
Sir, in synchronous sir, because in induction motors, our main motto is to increase for a high power factor is the main motto, sir, in induction motors. But whereas in synchronous machines, our motto is to be make it stable. That for that
Okay.
reason, we are adjusting the air gap in that manner, sir.
Okay, Lanka. I'm giving you the review. Look, the question is for any machines. Okay, you must be clear that why the
Yes, sir.
machines is being rotating and what are the reactions and why the reactions occur.
Yes, sir.
Right. What is the constructional feature and how this construction feature achieve in adding the more efficiency, adding the increase the efficiency of the motor. Okay.
Yes, sir.
So for having armature reaction, armature should be present and it should be the flux should encounter. And for case of induction motor, armature is itself present in the field.
Yes, sir.
Yeah. And talking about the air gap,
Yes, sir.
if the air gap is more, then it lead to the overall reactance to be more,
Yes, sir.
right?
Yes, sir.
Less, because armature reactance is more dominating about the leakage reactance in case of synchronous machine, and
Yes,
it
sir.
is less in the case of induction machine.
Yes, sir.
That's why air gap is more or less. So the task for today, I'm giving you the review feedback. Like you have to go to the machines constructional wise, usage and application. I have
Okay,
not
sir.
touched the single phase induction motor, so please go through this.
Okay, sir.
Okay.